Hello students, welcome back to my channel Infinity Minds where maths is made easy. Today we shall be doing page number 107, question number 3, 4 and 5. Chapter 4 of Ganita Prakash-I, Quadrilaterals, class 8. Okay, so let us begin. Question 3 talks about find the remaining angles in the following trapezium. So there are two parts. For any information regarding the properties, details, you must visit to the first video that I have put up on quadrilaterals, types of quadrilaterals and their properties. So trapezium is a four-sided polygon, a quadrilateral in which only one pair of opposite side is parallel. Only one pair of opposite side is parallel, okay? Unlike the parallelograms that we've been doing, both pairs parallel, both opposite pairs parallel, okay? So when one pair of opposite sides are parallel, the other one shall act as a transversal. If I have this side AB to be parallel to CD, AD shall act as a transversal. So interior angles on the same side of the transversal are supplementary. We can easily have A plus D to be 180 degrees, which makes me get the value of D to be 45 degrees. The very same logic can be applied to the set of B and C also, adjacent supplementary between the pair of parallel lines, or else there could be another way, like I've been discussing. There are multiple ways to solve in all such questions. Isn't that good enough, children? If you're able to think of something else, that is good enough. That's brilliant for you. If you think something on your own, you never forget. Anyways, coming to this, yes, you could repeat, apply your rule of co-integers to be supplementary with B and C as A and D, or else once you have the value of three angles in a quadrilateral, using angle sum property of a quadrilateral, we can get the sum of the four angles, angle A plus angle B plus angle C plus angle D, to be 360 degrees. Remember, angle sum property for a quadrilateral is 360, not 180. 180 used to be for a triangle. So if I have the values of three of them, I can put the values and solve for my missing value of angle D, fourth angle. Adding all of them, do transposition, you will surely get this to be 75 degrees. Okay, let's move ahead. The second part is also very similar. In fact, easier I would call. So the arrow talks about the set of one pair of opposite side to be parallel. At the same time, there is another, the non-parallel equality, that refers to an isosceles trapezium. Remember, and there was one property of isosceles trapezium that we had done, that the base angles in an isosceles trapezium are equal. So which would be the base angles in this case if I have side AD to be equal to side BC? Yes, angles opposite equal sides. After all, what does base angle talks about? It talks about the equality of angles. The way sides are equal, hence angles opposite equal sides. Now you would say, ma'am, to side BC, which angle is opposite? Is it angle A or is it angle D? Because earlier it used to be a triangle. So for triangle, the angle opposite to the side, there was clarity. But in this case, yes, it's very much true that A and D as such both stand opposite to BC. Then pertaining to angle A, try and remember, children, it is along the baseline. If I am talking of angle A, it would come out to be equal to angle B. Then in this case, we mean to say angles opposite to side BC, angle A if I am taking, then correspondingly I shall take angle B opposite to side AD. Got it? Like as such, A and B are lying on the same side as two endpoints of the same segment. Similarly, the equality of C and D shall happen. If this is an angle with a star, so probably, then I am also making this that talks about the equality of C and D. Angle D can also be considered opposite to side BC, which would fall to be equal to angle C lying opposite to side AD. The two, in a way you could say two base angles. Base angles A and B are base angles. C and D are base angle. These two corresponds and these two corresponds with each other. Okay. There could be multiple ways to solve in this also. Let us go through the one which is placed. Then I could discuss any other also if I'm able to share the answer. Angles opposite equal sides. So hence I get C and D to be 100 degrees each. Okay. So I'm able to solve these two. Now A plus D, lines are parallel, AD acts as a transversal, interior angles on the same side of the transversal, supplementary. I can get this to be 180 degrees, total to be 180. Same thing I can apply here and I will get this to be 80 degrees. What else can I do? If I had got this 80, the other 80 I could have got with angle sum property also, right? Another one. Another one could be applying angle sum to all the four. That is, supposedly I choose both of them to be x each and these two are 100 each. And then I say A plus B plus C plus D is equal to 360 degrees. Then solving for x, that could be another way. Got it, children? Almost three types of solutions I have discussed with you in the same question. So it is up to you. One is equality as an equality of the angles, base angles, and then seeing how you wish to proceed. Is it through angle sum property? Is it through co-interior supplementary? Got it? Whatever is you are comfortable. Always write, solve writing your question answer, solve your questions. Even if you've gone through the slide, practice writing it down. Penning down answers will make you master the skill of solving. Okay? You may come across another way of solving. First and foremost duty in the chapter of quadrilaterals is to master all the properties and the types. Only then, I hope it is clear, only properties are helping you solve this, right? So you must have your properties in place in your mind. If nothing, make your diagrams of various shapes, various types of quadrilaterals that we have studied. Make their diagrams, write down their properties. All this will help you solve your questions. And then solving questions. That has to be the way to proceed in this chapter, the order in which you must proceed. Okay. Coming to the next one, question number 4. Draw a Venn diagram showing the set of parallelograms, kites, rhombuses, rectangles, squares. Then answer the following questions. Yes, I have shared the answer slide straight away with you. This is the one. It's not the same, but this is the very same as in I haven't copied the same, but this is the type which is there shared in your textbook also. The last page of the textbook contains this as your knowledge, as your summary point that okay, all this we have discussed. We have discussed this in our first video also that I have put up. You may find the very same diagram. Eventually we reached this. The diagram which is there in the book and the when I'm talking about the last diagram, that includes the set of trapeziums as well. Where is trapeziums placed, children? Right outside their trapezium is placed. Okay, so it depends on what exactly is asked. Accordingly, you are required to have your Venn diagram. In the sense, for example, if you were only asked for the very first Venn diagram that we did was of square and a rectangle. Then our diagram was this, where we had talked about that a square is a rectangle. So rectangle is right outside. But as with the inclusion of rhombus coming in, our diagram slightly changed to this. The common is your square. It pertains the properties of rhombus as well as rectangle. So it isn't the logic has changed, but the shape keeps changing. Similarly, so when you are expected to include all these, eventually that's the kind of diagram you come up with. Well, starting from the innermost, the double shaded, this is your set of squares. So this is the one I was talking about, that this is my rhombus. That's your rectangle. In between is your square. All of these are nothing else but parallelograms. So there's a superset parallelogram, thereby containing all of these. And then kite is coming somewhat off track, as first of all, for sure, it's not a parallelogram. It doesn't have both pairs of opposite sides to be parallel. So only some part of it features are common. All this has been explained in my first video. Okay, you can go back, you must listen to it if you don't remember. As far as drawing a Venn diagram, yes, up to a certain extent you are required to remember, learn it up and present your diagram. Okay, moving to the set of questions. The idea of questions, see, there are two ways children questioning can be done. As of pertaining to this question, the question expects you to refer. What refer? It is understood. Once you have the diagram, you can refer an answer. No one's stopping you from referring. Referring can be helpful. It can be of help, provided your diagram is correct. It shouldn't happen that you land up making a wrong diagram, just in case, right? I'm just discussing the way children think. Secondly, another thing could be there is no diagram asked. Straight away questioning is done. Straight away question is asked. Fine. Well, that can be done. Even without diagram, you should be able to answer. That can be one point, valid point. Second valid point could be you could have this diagram. No, who is stopping you from having the diagram? It is, and that can be, it's not asked, fine, but you can always support your answer with the diagram, or probably you can have it in rough and help yourself answer the questions. Got it? It's up to you. But as of that's the perfect way to have your diagram followed by questions based on this diagram. In a way, you refer to them and answer. Which is the quadrilateral that is both kite and a parallelogram? Okay. First question talks about something which is both kite and a parallelogram. The answer to it will be a rhombus. If we go to our slide, kite and a parallelogram. In this diagram of kite and a parallelogram, can you spot out something which is common, which is falling in both? See, I have highlighted this. This falls to be part of your kite as well as parallelogram. So that's the point that diagram is helping you. Next, the set of rows. So let me just take a reading of the answer with you. Quickly, we'll take a reading. First part, what is the quadrilateral that is both a kite and a parallelogram? The set of rhombuses is common to both the set of kites and the set of parallelograms. A rhombus is both a kite and a parallelogram. Next, part number 2. Can there be a quadrilateral that is both a kite and a rectangle? Well, children, there is quite a debate over this. The book supports no, there is no such answer. Well, as you can see, I personally feel, so that is why I have shared this answer, that it's not visible, the shade I am taking. Well, as you can see, this particular portion happens to be part of both your kite and a rectangle. This is part of your kite and this is part of your rectangle. This is a set of rectangles, children. So this is the rectangle thing happening. And from here the kite is coming. So square, of course, happens to be both kite and rectangle. Next, is every kite a rhombus, or is it the correct relationship between the two types of quadrilateral? At times I can say yes. This is quite an important conclusion for, maybe it's one of the favorite of the teachers. The correct relationship is that every rhombus is a kite. Okay. So as we are saying, every rhombus is a kite. In the sense, as you can see here also, we are highlighting on rhombus as a kite. Rhombus is of course a parallelogram. It's a type of a parallelogram. There is no denying. Square used to be a rhombus when we had our Venn diagram. Square is a rhombus. Rhombus is a kite. Square and rhombus is both are parallelograms. Yes, they are quite overlapping. For students, it's not easy to remember. Well, coming to every rhombus is a kite. If you are unlucky, you are also at times asked, give reason. When I'm talking of, no, that without Venn diagram, give reason. say the same question could be reframed as give reason or one line support answer as to why every rhombus is a kite. Not asking you what is the correct, but telling you that every rhombus is a kite, asking you the why. Okay, if you get stuck in such a situation, the easiest way to answer is talking about the features of the lesser one. As you know, we had decided on how we decide that how every square is a rectangle, square is a rhombus, but not the vice versa. Square is a rectangle, but not reverse. The one which has more features is part of this. Between rhombus and kite, of course, rhombus has more features. So rhombus could be called a kite, but not vice versa. So we shall talk and enhance upon the features of kite. What all features does kite has? What all qualities does a quadrilateral requires for itself to be qualified as a kite? Or rhombus requires that if I call it a kite, will it be correct? For something to be a kite, it must have a pair of adjacent sides to be equal. Yes, in fact, rhombus has more. Then we will, it's like talking from perspective of kite. We have one of the diagonals perpendicular bisector to the other. Of course, here diagonals are perpendicular bisector. Here both may be perpendicular bisector, but here one is for the other one. Then we shall talk about the properties of kite. Okay, this I just at times go off track explaining you things more in depth so that your knowledge is complete. Coming to this question, okay, the correct relationship is compass is a kite. Okay, so going to question number 5 now, that is also a solving question. If pair and rods are two rectangles, they have shown you the diagram, they are kind of intersecting rectangles. Find the measure of angle IOD. Let me change the color of the pen. Find the measure of angle IOD. This particular angle they are talking about, children. Okay. So let's see if you notice these are lines are parallel. This would act as a transversal. This particular would also be 30 degrees alternate angles. Angle O is of course supposed to be 90. If the part of it is 30, the remaining would be 60. And similarly, angle O, kindly see to it children, in rectangle RODS rods, angle O alone stands for 90 degree, of which if 60 is already occupied, you would be left with 30 degrees. There are multiple ways of solving this, and I would term it under an easy question. Okay, it is not a difficult question. Mainly your knowledge of rectangles and little bit of common sense is being used. This is one of the ways that I have shared. Like this is a pair of alternate, then the total to be 90. So 30 plus 60 and again 60 plus 30 shall make it to be 90. That is one way. Can you think of any other way, children? You must be able to think of different ways. The more you think, more confident you become. Okay, now let me discuss another way. This is already given to be 90. So this particular portion can be 60 for you. In triangle RIO, using angle sum property, I of course is 90 degrees. So this would come as 60 degrees. Now again, in rectangle RODS, angle O is supposed to be obviously 90, of which ROI is 60, so IOD would be 30 degrees. Clear? Okay, so with that we come to the end of this particular part of the video. Rest of the exercise I shall cover up in the upcoming videos. Do keep watching, do like and subscribe to my channel and keep practicing. Thank you.